Now, letter H is a little bit of a review question. Suppose these data were gathered from looking at the public records and CDC data for teen births, which is exactly where they came from. So if that's the case, then what kind of study is this? So I just wanted to remind everybody what the four types of studies were that we learned in section 1.2. Designed experiment needs random placement, right? The researcher has to randomly put people into groups, which definitely is not happening in this case, right? You're not assigning teen birth. That's not a thing. So observational study that is cross-sectional is when you're taking a snapshot in time, right? Right now, you poll people right now about how they think about the US or what they think about teen pregnancy or whatever. Case control is when you're looking at records, usually from the past, right? So past records from databases to analyze the present um, or to make judgments, which is definitely what's happening in this case, right? We're looking at the public records, right? Ding, ding, ding. That's past records. Cohort is when you're tracking a group over time. Those are often called longitudinal studies because there's a famous one with a whole bunch of nurses, tens of thousands of nurses, and they track them every 5 years. They catch up with them and take data measurements from them. Okay, explain why we cannot say that having higher household internet access in a state causes the lower teen birth rate in a state. Ah, okay, so that magic word causes is a problem for us, right? It is true that states that have higher internet access do have lower teen birth rates, but correlation is not causation. And that's because of lurking variables. All right, so here's our correlation is not causation script. So we have to think of some lurking variables that would impact both our x and our y, right? So the y was the teen birth rate, the x was the internet rate. So what is something that would cause a state to have, say, more internet and lower teen births? Well, income, right? So the wealth of that particular state, right? So wealth would impact both of these things, right? Income, education level, right? What percentage of your state has high school diplomas, right? What percent of your state has college degrees or post-secondary work, right? Having a more educated population, you might imagine, could impact both of these things, right? Infrastructure, right? Those kinds of things, right? How many hospitals are there in your state? How many hospital beds? How much, care is there for pregnant folks in your state? That could also impact internet rates because, right, there's wealth going on. Right, so you're looking for a variable that's impacting both of these, and these three would be a good one. Although wealth and income are really the same thing. All right, so find y if x equals 89.4 using the linear regression equation and interpret these values in the context of the situation. Okay, so we have an equation that we already found. It's right here. So y hat was equal to, so we're going to write that down. Y hat was equal to 182,446 minus 1.857 x. Sorry, my 5 got strange there. There we go. Okay, so what we're going to do is they're telling us that the x is 89.4. So where there's an x in this equation, we're going to put it in. It's called substituting. We're going to substitute that value in for x. So I'm going to put in a parentheses to indicate the multiplication. And there we have it. Notice, by the way, that we use 89.4. We're not changing it to a decimal because the table uses big values. Right? So we just leave it like it is. And we find that with Desmos. So let me go grab Desmos. Okay, so 182.446 minus 1.857 times 89.4. Or if you prefer, you can use parentheses. Either way, it's fine. It still knows what it is. Right, so it's 16.43. Okay, so that's all well and good. We found the y, but what does it mean? We have to interpret these values in the context of the situation. Well, this isn't anything fancy. All you're doing is kind of tying back to what the variables are. Do you understand that this is x and this is y? So what was x? X was the high-speed internet rate. So a state that has a high-speed internet rate of 89.4 internet rate of 89.4% of households, or 89.4%, right, there's the X, is expected to have, we don't know for sure, but is expected to have a teen birth rate, right, that's the Y, of, actually we put of here, of 16.43, and then remember the unit for that, that was births per 1,000 women aged 15 to 19. So all we're doing is kind of putting the X in and what it meant, and then putting the Y in and what it meant, right? So this is the Y piece right down here, and this is the X piece. And it's not really a script, it's more just tying back to what the variables were and what this context was. Do you understand the units? Do you understand the variables, right? You're proving that you understand this is X and this is Y and what that meant. All right, now Michigan actually had a teen birth, or an internet rate of 89.4 in 2021 and a teen birth rate of 15.1. Find the residual for Michigan. Okay, so the residual formula, let me write it out here. Residual formula we've learned is the actual Y minus the predicted Y hat. Right, that's the residual formula from section 4.2. So the actual Y is right here, right? It's telling us they really had 15.1. So the reality is 15.1, if you like, births per 1,000 women, right? Minus the prediction. And the prediction we made was 16.43 births per 1,000 women. I'm just abbreviating that really quickly. All right, so now I need to find that subtraction. So I need to grab Desmos and say, hey, what's 15.1, the actual value for real life Michigan, minus 16.43, and we get negative 1.33. So this is negative 1.33 births per 1,000 women aged 15 to 19. I actually have room to write the whole unit this time. Now, what does that imply for Michigan? So we were expecting 16.43, but we had 15.1. So let's look. First of all, it's a negative residual. So it's going to have to be one of these first two because that's a negative number. So there's no way it's these two because they say positive residual, which is not the case. And then let's think about the numbers. Michigan was actually having 15.1. 15.1 is lower. They're having less births than we expected due to a negative residual. Now, whether you want to count that as Michigan is doing well or poorly is kind of a judgment call. Usually teen births is not something that you want a lot of in your state. So we could argue that Michigan is doing well because there are less teen births than expected, or fewer teen births than expected. But remember, the whole idea of being well or doing badly is kind of a judgment call that we're making based on how we feel about teen births as a society overall.